I would like to start my presentation by thanking you for the invitation to present at the Architecture, Media, Politics and Society Conference on Experiential Design. My name is Moustaka and I'm a faculty member at the University of Salford in Manchester, UK. The central theme running across all my research is related to materialist philosophy and what it can offer to architectural theory. Within the theme of human-object interactions, my work follows two distinct strands. The first one relates to the role of materials or objects of the built environment, both in construction and in everyday use of buildings, and the way that we interact with them. The second strand of my research relates to architectural education and more specifically the interaction of design students with computers and what this interaction means for the designed object. This is the area that my presentation will focus on today. The purpose of this presentation is to question and reposition what traditional model-making practices in architectural education have enabled, and how the transition to digital model-making ultimately also means a paradigm shift in the ways that we produce, manufacture, design, use, and experience architecture. To do so, I will argue that the shift that has taken place in architectural production from physical model making to using digital means of fabrication has not only created a shift in the way architecture is produced, but also a shift in the type of architecture produced. This just about sums up the paper I'm about to present. I begin by arguing that the change of medium from the physicality of a material to the terrain of a virtual environment is at first glance a simple change of medium, a change in the tools and techniques used. But because it involves a different type of interaction, a different effect is produced. The paper investigates examples from student work and concludes that the physical handling of matter informs the development of ideas in architectural and design education in a different way than the engagement with a digital tool because of the different experience the software affords and because of the different embodied experience that an object's materiality offers. The move from manual to the digital involved a wide array of software and tools, and not all of them can be included in the presentation. Various versions of Autodesk software, for example, AutoCAD Architectural Desktop from 1998 to 2006, ArchiCAD and Revit all include ready-made components to be used in the process of design. Other software, such as Grasshopper and Dynamo, require the designer to program in their interface by inputting parameters. The philosophy of the produced design, when using these different pieces of software, is not simply a difference in the interface used. As I will present in some cases, a designer is dealing with a predetermined number of components that are pre-existing in a computer. They have little control over these components, and whichever decision they take to include whatever they need in their design, they need to use these components as their starting point. In other cases, the user has an apparent freedom to design by inputting information, but still relying on a software developer for the relationships to different types of information included that will ultimately shape the output. Although the introduction of digital tools revolutionized architectural drawing, the shift in architectural production from the physical to the virtual has not always involved a major shift in the attitude to design. For example, as I have been able to witness in person, drawing on 2D AutoCAD in the early 90s, the commands needed to be typed and coordinates were inserted manually in the software. The production of the 2D drawing on AutoCAD during its early days was a simple change in medium, not a changing shift. Instead of using pen and paper, there was a simple transition to a keyboard and screen. The ways of organizing a 2D drawing were the same, but the tool changed. Of course, with this transition came a visual shift in the outputs produced, but the logic of drawing remained the same. Plotting a drawing instead of drafting it on a drawing board still required a calculation of how to center the layout, identifying an appropriate scale to make your drawing fit the page, or the other way around to find what page size you should be using to fit your drawing at your desired scale. The rationale of creating a drawing in this way was shared by drawing board and computer users alike. While the produced outcomes had slightly different graphic qualities and the production in one involved a plotter, The actions of creating a drawing between the two methods was not far apart. It required a similar type of thinking and a similar process. Physical tools that had been previously used were replaced by commands. The rapidograph was replaced by the command line. The tracing paper was replaced by copy clip. The compass and French curve by circle and arc respectively. This was therefore a simple swapping of tools, not a groundbreaking shift in the methods used in architectural production. And all these changes can fall under the umbrella category of manual design production as presented in the table. The move, however, to architectural creation in a 3D environment where the user is interacting with the software to simultaneously visualize and create a space, create a building, or create an environment for an activity for a user, marks a shift in the way that design is produced. This shift in the entire approach to design originally took place when 3D design started developing from a set of ready-made components. Software like Architectural Desktop and ArchiCAD introduced this move to designing with components. Every object, library, component in these pieces of software was predetermined, and the designer had to rely on what was available to work with in order to create a design. It marked the first point of taking away some of the agency of the designer. So I'm starting the presentation of this category with this image from the work of Paul Coates that demonstrates the move from CAD to BIM. Components that were not ready-made were very difficult for a software user to input or create from scratch and required a very experienced software user. Hence, design ideas that were not possible to be visualized through the objects or libraries or components already included in the software had to be abandoned in favor of ones that pre-existed, leading to a design with components. The emerging design result from these software is therefore an outcome of the pre-existing versions of the object that are already included and have been placed there by a software developer. The degree of personal input is limited by the choices made by a developer to include or not a component. The agency, therefore, software developers have over the creation of a design is not to be underestimated. A choice made, for example, somewhere in Autodesk's offices in Massachusetts or California informs what a designer is attempting to produce in Japan or England. The genealogy of decisions, for example, about a wall that is designed by an architect in India may be traced back to a desk in San Francisco. Some of the creative actions of design are delegated to the machine. This deterministic effect of component design architectures was not as evident in other software such as 3D AutoCAD and in dynamic modeling 3D software as Rhino and 3D Studio Max. For a designer, 3D Studio Max opened a world of modeling possibilities to a designer and enabled a myriad more ideas to be designed on the computer. They also had the ability to simultaneously move the designed object in space while designing. The effect a gesture made, for example, in a building's elevation was simultaneously evident in its plan and section. This type of approach was similar to producing a design through physical model making. In the same way that an architecture student could manipulate a physical object to create a design, these software programs enable the user to visualize the effects of design gestures simultaneously in 3D. The cardboard and pen knife, for example, of a physical model making was replaced by the creation of a plane that represented a wall in 3D. Similar to how a designer would create a wall in the working model to understand its effects in space and enable him to visualize its extensive properties, the 3D wall on this software could also visualize this on the computer. The designed object was created de novo, without any predetermined software effects, with the designers retaining their agency on the designed outcome. Dynamic software, however, were introducing another form of computer-determined architecture. Because the dynamic modeling capabilities were also decided by software development, they had the capability to model dynamically effects of movement, explosions, interactions of objects and performed calculations applying the laws of physics on the object modelled, but only based on how these options for dynamic modelling had been introduced in the software. More recently, designer software has seen another change in its attitude, as it can be produced through code writing in Grasshopper and Dynamo. A designer in these software is the author of the information input that will shape the design outcome, but is reliant on the programmer to be able to produce relationships between the types of information included. The outcomes of such software is often coming as a surprise. The input is in the form of information and the output is authored by the machine. The different design philosophies or approaches to design in the different types of software can be summarized in the table. From this summarizing table I've just presented, two types of observations can be raised. One of authorship, for which I draw inspiration from previous work by Antoine Picon, and one on empathy, for which I will draw from the work of the Finnish architect Juhani Palasma. Starting with authorship, Antoine Picon was the first to make observations about the degree of input of designers in his book Digital Culture in Architecture. He has presented how the NURB SP-line has contributed to an entire genre of buildings in architecture called blobitecture. The inclusion of a non-uniform rational BSP-line command, an AutoCAD function, has allowed the creation of extrudable curves in the late 90s, and it was the reason behind the emergence of a blob, a curved form that trended in architectural publications and research for a few years in the previous decade. Another example is that of the Kartalpendik neighborhood in Istanbul, presented by Patrick Schumacher, where the information is input by an architect in the computer and the forms are generated by the machine. The question is, where does this authorship of the future architect in this scenario lay? A second observation on the design methods can be made on empathy, for which I draw from the work of Juhani Palasma. Design research has acknowledged the importance of empathy in design, but as design is gradually moving from the architect being in control of the design gestures to the computer being the author by means of an algorithm, the empathy involved in design decisions comes increasingly unnecessary. The architect does not only lose the authorship of his product. The new generation of architects can produce spaces void of their ability to relate to their users. Their sentient ability to connect to others becomes less and less necessary as the design moves to ready-made environments and further into a design where the machine claims significant authorship. At this moment, it is worth switching to Design Studio to identify how these different design philosophies affect the outcomes for design students and what observations can be made. The arguments presented here are the results of two cohorts, one studying architectural design and technology and one studying architecture. Two distinct pedagogical approaches have been followed for each cohort. The slides that follow present work samples of the two cohorts. The two groups were being taught in the same semester and therefore running in parallel at the same university, and their design studio was led by myself in both cases. But the first one was asked to design solely using sketching and manual methods of model making without having any knowledge on how to design on the computer. The second one was learning how to model in 3D on Revit while they were expected to deliver their designs, so they had to develop their design while learning how to use the software. They were asked to use exclusively a digital model where they needed and to refrain from producing physical models. The findings are observations made by myself as instructor and based on the work that has been produced by the students. All of the students involved were first-year students with either minimal or no prior experience in the design. This means that they were learning to design almost from scratch. While this sounds as a challenge, it presents an opportunity to an instructor to guide the student through different approaches for design. In observing the architecture students in their model-making process, it is evident that the tactile experience of designing through a model that is omnipresent in physical model-making has disappeared when using the computer, making the experience a visual one. Physical model-making is an experience as tactile as much as it is visual. Furthermore, models allow architects to view inside them, either by naked eye or modelloscope, and being able to experience in the physicality of being in these spaces, something that is lost in the digital, since the only way to understand is through a 2D screen. Even when the object designed in a virtual environment is in 3D, it is experienced in a domain where it feels artificial and two-dimensional. As presented in the ethnographical accounts of Albina Janeva, the physical manipulation of architectural models is a reciprocal interaction involving the designer and the object. She presents through her work on OMA the way that architects rotate, look into, tactile, and imagine through models. Janeva calls this interaction a dance. A similar ethnographic observation of architectural production in the studio reveals a similar observation. It is a holistic experience that involves a range of skills and materials used and a range of actions performed. Through this process, a student develops the ability to know exactly how much pressure to exert on the cutting knife to cut through his 3mm cardboard, what type of glue, and the quantity needed for the type of connection he wants to create. Albina Janeva calls this process of continuously being transported from the physical model to the imaginary potential a rhythm. She does not see it as a linear process that architects follow to arrive to the building as a known, but as a continuous dialogue between architects and materials and shapes. Within these dialogues, Janeva claims that there is continuous movement between what is less known and what is more known in buildings, and this movement is continuous and non-linear. The process of design materializes in physical model making because it involves an embodied and empathic interaction with the physicality of the design process. The designer's choices need to describe to future users their needs in ways that they never realized. One often used quote is that of Sir Denis Lasdin. It is not what the client thought he wanted, but what he never could have imagined existed. With the physical model-making process, the architect develops an affinity to the client, becoming able to materialize his client's needs and desires. Model-making enters a dialogue with fellow designers at the same time in the studio and becomes a group-generated activity. Beyond being a simple space formation activity, the architect develops the ability to relate. Moving on to the other cohort of students in architectural design and technology trained with Revit, the students, because of their little ability to use the tool, sometimes run the risk of creating spaces non-intentionally or incidentally, and creating spaces that have started as one thing but have ended as another. So we can look at examples where the students, because of their limited ability to design and their limited ability to use Revit, they create designs based on predetermined material choices, so they allow the software to make a material choice for them, used as a default choice on Revit versus an informed material choice, or absence entirely of any materiality, surfaces, or without any materials or textures. Creating spaces with predetermined state of materials with repeated patterns regardless of scale. Relationship to context, so a lot of buildings that are not connected to the surroundings, and absence of empathy, particularly demonstrated with the absence of any human presence in the spaces that they design. The change that is occurring in the way architects are designing and their move from the physical to the virtual may be parallel to the prehistorical introduction of a new tool to mankind. Architectural designers are at the moment reducing the use of a physical manual tool and moving to a virtual tool. To understand what a major shift between tools can inflict on the neurophysiology of humans, it is worth going back to the moment in time when humans first started interacting with objects as tools. Revisiting this time may be helpful to understand the change this shift has inflicted. According to Lambros Malafouris, the introduction of the physical act of tool use in Neolithic age initiated a drastic change in the formation of a sapient brain. To use his own words, tools actively and meaningfully participate in the process by which the hominin brains and bodies make up their sapient minds. Furthermore, this process he is referring to is not limited to the formation of the brain, but assumes an active and reciprocal participation between object, body, and mind. This observation from the field of archaeology can have a serious and meaningful repercussion in the way we design in the studio. Moving the design process away from the manipulation of a physical materiality to the manipulation of a virtual environment, mostly visual and involving different means of communication with the design, can result in a complete change of the way an architect's brain is formed and shaped. This theory of material engagement, which argues that the historical engagement with artifacts has influenced our cognitive evolution, when applied to the shift from manual to digital design production, can have far-reaching implications. Designers are no more simply professionals with a heightened spatial understanding. The ways in which they are taught to design can involve an entire cognitive change. I would like to conclude by pointing out that similar to the effects the introduction of tools had on the Neolithic brain and its cognitive abilities, it is worth arguing the shift I have described between using a digital model to design have an effect on the cognitive abilities of the new generations of architects. The effects, similar to the shift they had on the sapient brain, may be repeated in this shift in architecture. So I will wrap up with some rhetorical questions. Could we be witnessing a cognitive evolution for architecture? How are the cognitive abilities to design affected when using a manual or a digital tool? What assumptions can we begin to make for the future of design? What types of environments are young architects being rewired to produce? And what about the future of cities? How will the cities of tomorrow be shaped if they will be designed by the new generations of architects undergoing this cognitive change? Thank you for watching the full length of my presentation. If you have any comments or feedback, I would really appreciate some input, so please do get in touch if you have anything to say or you would like to have a discussion on the subject area. It would be great to have a discussion to hear what you think. My details can be seen on the screen.